Good afternoon, Algebra 1, 8-8, difference of squares. This is one of my favorite patterns because when you have a square minus a square, all you have to do is think square roots. One with a plus, one with a minus. So when I look at this is a perfect square. This is a perfect square. It's got a minus in the middle, so it fits the pattern. So I'm just thinking the square roots. The square root of 2m squared is 2m. 4m squared is 2m, so I'm going to have 2m plus and a 2m minus. The square root of 81n squared is 9n. And I'm done. Okay? Now sometimes you have to see, I look at this one and I say, well, 50 is not a perfect square and 72 is not a perfect square. But if I divide out that GCF of 2, I get 2 times 25a squared minus 36. That's a square, so it fits my pattern. 2 square roots, 5a plus 5a minus the square root of 36 is 6, and now it's done. Okay, now sometimes they're going to be hidden in these foursomes. Now, when I look at this, I'm looking at those numbers 4 and 8. They're both divisible by 4, and they all have an x. So I can pull out a 4x. What am I going to have left? I'm going to have an x cubed plus 2x squared minus x minus 2. Okay? Now, what do we do with when we have 4 terms? We factor by grouping. This is my GCF. It'll come into play later. Okay? So I've got to break this down, and the GCF of those two is an x squared. And x squared, I'm going to have a 2 left here. Now I need an x plus 2. They're both minus, so I'm going to pull out a minus 1. That gives me my x plus 2. Here's my new GCF. I got to pull it out. What's left? X squared minus 1. Uh-oh, there's my difference of squares. Got to break it apart. That gives me an x plus 1 and an x minus 1, x plus 2, and I bring in my GCF of 4x. Fourth power, 4 factors. Okay? Now what do I do with this one? I got a 4th power. Well, that's a perfect square. Okay, so I can do the square root of this. The square root of this is 4x squared. That's a perfect square, so I'm going to have 4x squared plus 4x squared minus square root of 81 is 9. Okay, uh-oh. There's another difference of squares. This is prime. Okay? Because this says the signs would be the same, in which case I would have a sum in the middle, and there isn't one. So this part's prime, but this part I can still break apart. Square root of 4x squared is 2x, so I'm going to have a 2x plus, 2x minus, square root of 9 is 3, and I copy my first one. Okay? All right, what do I do different when I'm solving? Not much. Okay, so this is a perfect square. Yeah, it's a fraction, but guess what? It's still a perfect square. Okay, square root of x squared is x. I'm going to have an x plus, x minus, square root of 1/25 is 1/5. Okay, now when I solve these, that just means this is going to equal 0 or this is going to equal 0. So x equals negative 1/5 or x equals positive 1/5. And I can write that as plus or minus 1/5. Okay, so notice, hey, they're the same. Okay, let's look at another one. 4x cubed equals 9x. Well, what's wrong with that? It doesn't equal 0. 4x cubed minus 9x equals 0. Ooh, GCF of x, they both have an x, got to pull it out. And that gives me 4x squared minus 9. Gosh, didn't I do that one before? Okay, so that's x times 2x plus 3, 2x minus 3. 3 factors, 3 answers. Well, this one's just going to be 0. This one would be negative 3 halves or positive 3 halves. So plus or minus 3 halves. 3 answers, 3 factors. All right. Now I look at this one and you're probably saying, oh, difference of squares. But when it says to factor completely, I've got to look for that GCF. There is a GCF in those two numbers. So I need to divide it out. Now because it's just a number, I can divide it out completely. Okay? And that gives me m squared minus 4 equals 0. Perfect square, m plus 2, m minus 2. So m equals plus or minus 2. Hope that helps. We'll see you soon.